Welcome to IT-426. Many of you were able to make it on Thursday night, and I thank you for that. For those of you that were not able to, or for those of you that wish to see a little bit more extra PowerPoint, this is the general brief consensus of what is going to be in Chapter 1. I'm not going to touch on all of the points in detail as they're in your book, and they're also, you can read them in the PowerPoint. So I'm going to touch on the things that are important, and hopefully you will get a lot out of it. So obviously, we are IT-426 database systems. And Chapter 1, here are your learning objectives. These are also in Canvas. The little delay was my mouse was not working, so I am now presently using my keyboard. And again, continuing more learning objectives, you can see about that. Basically, the concept that you need to learn is what actually is a database and why should we use a database instead of a flat file such as an Excel spreadsheet. So the very first thing I've come up with is what is need for a database? Well, obviously you go every morning and your data is all over the place. You start your life with a birth certificate, you go to school, you get grades, you live in different addresses. These are all data. Take a look at sports. Everything now is all data analytics. You can go and see when this person grounded out with 2 outs and a runner in third base at 2 o'clock in the afternoon. That's how much data is stored. And again, anytime you buy something, everybody, I'm sure, buys something from Amazon, and you have something delivered from FedEx, you get something in the mail. These are all things that need data, such as where are we going to deliver it? Where does your customer number? What order are you getting? What is the price of the item? How many of you? What color? So all these things are part of a database. So here is a simple definition of a database. It is nothing more than an organized collection of integrated and related tables. Think of a table as like an Excel spreadsheet where you have rows and data. The columns usually represent fields, and the data represents like records. So, and again, a table is a collection of related fields, which is what I just described. It's often called an entity. I prefer to use the word table. If you prefer to use the word entity, that is perfectly okay. Columns are like your headings, name, first name, address, city, state, zip, so on and so forth. Another common name for that is attribute. You can use either one. I normally use field. And rows are just a collection of it. So you would have a record, or you can call it whatever you want. But basically, the easiest thing is call it a record. Then again, here's a little bit more definition. Raw data is just a bunch of useless data. If I give you a number 3452, you have no clue what it is. It could be a zip code, it could be your weekly paycheck, it could be anything. And again, we have field, record, and files. This is, again, a table, a spreadsheet, so you can see the columns or attributes are name, job class, regular age, so on and so forth. The records include employee 1, 1, 10, 40, 15, 25, 40. That's a collection of all the fields or all the attributes, all the columns, whatever you choose to use. Database system is going to allow you to do the following. Records is going to add, delete, and update. Data, retrieve, sort, query, and report. Query is nothing more than a fancy name is give me a set of filtered data, such as I want to know all of the people that live in Miami. I want to know all of the people that have purchased something in the last 6 months. And again, entering the database, get very used to the word metadata. It's nothing more than data about data or the characteristics of a field. And you'll see some examples right over here. So we have an employee ID. Employee ID is an integer, which means it's a whole number, and it's a primary key. So it's telling you about that. The first name is, don't get worried about the N bar, char, and 50. We're going to be using varchar mostly in our Access database. That just means characters that can be a variable length. And then a description, first name, and then you can see department ID is an integer. Gender is character 1. That means it can only be an M or an F or a null. No means there's nothing in there. And then employment date is obviously needs to be formatted as a date. And here's another example of it over here. So you can see all the different fields that are available and all the data that's available about each data. If you take a look down here at the custom properties, allow data no, data type numerica, so on and so forth, precision, how big, scale, all these things right now make no sense, but as you get along, you will. And most of these things are all kept internally. You don't really need to worry about any of those things. Okay, introducing again the database called DBMS, Database Management System. It's basically a collection of programs, such as you're importing your thing, finding stuff, query, adding a record, deleting a record, modifying a record. All that's done is for you automatically. You as the end user are just going to follow the programs in here. And again, the role of the DBMS, I'm not going to really read all this stuff. You'll see that in here. But basically, just look at it as an intermediate between the user and the database. Again, more of the roles of the database detailed. You can read that in here so you can see the easy part is on you. The hard part is on the database. And it does the complex things for you so you do not have to do that. Again, more information on the roles of the database. This is an illustration of how the database works. So you can see you are the end user over here, end user over there. You put in your data. You ask, okay, add to cart. Well, it goes in there and checks your customer. Then it's going to have a detail file. It'll add all those things. And then later on, you can check out. All this stuff is done internally for you. Manage the DBS, simple. Data inconsistency is a nightmare. That is when you have different types of the same data. For instance, you could have a street that is spelled ST. You could have a street that's spelled STREET. How is the query going to find it unless it's consistent? So again, end user productivity is increased and improved data sharing, security, access, decision making. Data quality, if you don't have data quality, then that's a nightmare. So it's got to be. Data inconsistency, again, I just went over that a little bit, but you can see how is a database going to handle an address or a phone number that is stored separately ways. I gave you the street and the street. Here's a phone number. Types of databases, know them, they're really simple. Simple user database is what you're going to be using, and that's just one user doing it. You're not worrying about other people in here. A desktop database is a single user database, and it just runs either on your database or maybe you have access 365 in the cloud. Multi-user database supports multiple users at the same time. For instance, where I'm an IT director, we have a program called Redditor software that handles all of our student database. Well, we have 10 licenses, so 10 people in our school can access at the same time. So that would really be a work group database. I say that anywhere from 25 to 50 people is really a work group database. An enterprise database supports access all over maybe the country, maybe the state, maybe the city, have different things. For instance, Dade County Public Schools, they have schools in 100 locations, maybe more. That's an enterprise database. That all goes back to the main office downtown Miami. Again, centralized database, it all has in one site. Single distributed is data to different sites. Let's take Amazon for a second. Do you think all of their data is stored in one site? No. If something goes down, then they would be down. So they have it all separate. The same thing when you go to MSN. You don't know where you're actually going when you're going MSN. You could be going to one server, another server, and that's called data balancing, load balancing. If you've taken a security course, then you know about that. And again, a cloud database, that is what we have. Our database is not maintained on our own servers, which means if anything happens to our servers, no big deal. Anyone with an internet connection can get into our database in the cloud. Obviously, you have to have a username and password. Again, types of databases, general purpose, and discipline specific. A SIS is discipline statistic. An operation database is something that just supports the company's day-to-day operations, such as our Redditor software. That's what we do our students. We have a file library system that also keeps track of our library. The students come in, they check books out, they have a little tag. We scan the tag. It automatically enters their information. Then the book has a code. As soon as they scan it, it checks it out in their name, signs a due date, so on and so forth. Okay, and again, analytical database. Data warehouse really describes the information about the database. And I will give you an example in here. So basically, it's used to help you make decisions about what needs to be done in here. Unstructured data we talked about before. What is the number 3450? What does it mean? Structured means it's now formatted into something that can be useful. And I gave you the example, 37450, is it money, sales tax, or sales number, or zip code? Semi-structured data is often used as well as XML. Database design, again, focuses on the design, the structure that's going to be used to store. You're going to be needing to create different databases, and you're going to actually be creating ERD designs, which will have the layout of the database. It'll make you it's very, very helpful for you in order to design the rest of the fields. And here's, again, more basic file terminologies. Duplication of the same slide. Structural dependence is basically if an access to a file is dependent on structure, if you modify the structure, then you need to modify the access to it. For instance, if you add a new field, you may need to add the programming to access the record. Otherwise, it just won't work. Structure, you don't have to worry about it. Again, you can read more about that in the book. A little bit more information about structural and data dependence. Data redundancy, I'm going to touch on. Notice the Dr. ID, I'm not sure I feel comfortable going to either. Dr. Jekyll, I believe he used to be Mr. Hyde, now he's now Dr. Hyde. But anyway, take a look at Dr. ID, Dr. Hyde, and you see how he's duplicated in everything. So all we really would need is Dr. ID, and Dr. Hyde would not be kept in this file, would be kept in something else. It would be in a doctor file. And the problem with this is if Dr. Hyde decides to change his name, say Dr. Hyde is a female, and he marries Dr. Smith, well, you have to change Dr. Hyde into Dr. Hyde from patient 134, from 192, and 210 instead of one time. Same thing with the room. Maybe he moves rooms. So we don't want to do that. Again, here's another information on data redundancy, how the information is kept, the employee's phone, many duplicates, so on and so forth. We don't want to have it. Again, here's another example. This is from the video that you need to watch. You can see how many duplication in here. So if project manager changes for the OS upgrade, you have to change not only the manager ID, you have to change the manager's name, you have to change whatever else relates to him and his phone extension. Again, data redundancy, poor data. Data can be inconsistent because you have 5 things that need to be changed and you change 4 of them. Data anomaly develops when not all the required changes in redundant are made successfully. Again, you miss one. The video gives you a very, very, very good explanation of it. And there are 3 of them: update, insertion, deletion. And again, this is going to be the example that is going to be used. And this is another one he will go into heavy about. So you can see he says if Evasive Baker has changed the Tang, you need to change the email, and then you need to change Valdez. We need to change the advisor email, department, and last name. So you have multiple things that you need to change if you make one simple change. Then if you delete a row, so we're deleting Chip Marino, and the problem with that is the advisor is only advising him at that point in time. Now you lose all the advisor information. And now if you insert a new row and you have a new advisor and department, or even just a department, all the data that you have here is not going to be useful because there's going to be nothing in it. Last name, so on and so forth. So you would have a department, you would have an advisor. All these things would be kept in separate files, which you'll learn about shortly. And again, here's more information on database systems and what they do. But just remember, the rule of thumb is it stores the data structures, the relationships, which you will learn about, how the table's related. For instance, a order and an order line detail. Well, you're going to have an order number, and the order number is going to have who the customer is and probably the amount of the order. Then you're going to have an order detail, and it will link to the order number. Again, multi-user, backup, recovery, all these things are built in for you. Data dictionary stores the data, the elements, and the relationships. Here's an example of a data dictionary, which you make up yourself, and there's programs that will do that. You can see all the information that's there. Query language and structured query language, these are statements like select, insert, update, delete, where, sort. For instance, if I wanted to find all the people from this table that lived in Miami, I would choose select from, the name of the data table, and I would select then the field. So I would select last name, and these would be fields: name, last name, first name, whatever pertinent information I want, where city equals Miami. And that will give me all the information. Then I could sort by whatever one I could do sort by. Then we will be learning that in Chapter 7. So the student file that I showed online, which I'm not going to post, had both redundancies and anomalies. And that's it for this session. I will have the video posted online as well as the actual PowerPoint. Any questions, please feel free to give me a call or email me, and I'll do my best to respond as quickly as I can. Have a wonderful day.